So let's cover three basic problems for linear absolute inequalities. So let's start with number one. Let's say that we have a 3 absolute value x minus 3, and we're asking the question that if it's going to be larger than or equal to, let's go with a strange number. Let's go with 14, okay? So we're asking the question, what values of x? We're asking the question, what values of my variable, of my x variable, satisfy my inequality? So when I take a number, what number, when I subtract by 3, then I take the absolute value of that result, then I multiply by 3, which numbers and are larger or equal than 14? That's what we're asking. So again, let's start with our first point. So we get rid of the absolute values. We put an x1, which is our first point on our number line, and we put equals to positive 14. Okay, so I won't show this step by step. I have video. So firstly, I divide by 3. So x1 minus 3 equals 14 thirds. Oh my, we have a fraction because we can't divide it further. Next, I throw the number 3 to the other side. So we have 14 over 3 plus 3. Now, how do we solve this? We need the same denominator. So this will become 9 over 3. Now, 14 plus 9 is 25. And our first point, it can be a fraction, is 25 thirds. That's our first point on our number axis. I think I'll draw the point right now since it will fit. So let me draw a nice large number axis right here. I get infinity. I get minus infinity. I get a 0. And the point will be, let's say around here. Here is the point, whereas 25 thirds, that's positive. Let's solve the other side of, let's say, the absolute value inequality. So we're solving the problem where when we get the negative result. So when it becomes minus 14. And I think I did it wrong. Did I do it wrong? No, I didn't do it wrong. We're going to also check. So now when you're not sure, we can also check. So first of all, we're going to divide by 3. So right now we have x minus 3 is minus 14 over 3 x 2, apologies. So that's the second solution or second point on our number line, which is x2 equals minus 14 over 3 and plus 3. So we have the kind of the same problem, just it's a different minus sign. So we have to be really careful here. So plus 9 over 3. And this is the same thing as 9 minus 14 over 3. So my second number is negative 5 over 3. So that is my negative, let's say, so solution to my equation. So we can put it somewhere here. negative 5.3. Now, it's really important to check what kind of operator we have, what kind of symbol. Our symbol is larger or equal than, which means that I use a filled point to represent my interval. So I can draw a line. You can also draw it directly on the line. And also here, we fill the line. And it's larger than, which means that all of these numbers from this point, so from the 25.3, and oops, I made a mistake with the color. All of these numbers from here, including the point, is the solution. And all of these numbers from here. Now, I'd like to also write the, let's say, solution. So we can just call the domain with a D. It's nothing particular. So the first one is from minus infinity. Now, careful, this is 5 over 3, but with a square bracket. When we have a full dot, we can represent it by a square bracket. Then we combine the two intervals with a u, with a unity. And this is 25.3 to infinity. We cannot reach infinity, so that's why. Okay. So let's continue on with our second problem. Let's say we have something along the likes of plus 2x plus 3 divided by 7. I'm going a little crazy here. And is going to be smaller than, is going to be smaller than 1. Smaller than 1. So the first trick up our sleeve is that, hey, I don't need this fraction. I'll just simply put it on the other side. So we will rewrite our inequality. We simplify, always simplify when possible. It's smaller than 7. And now we will solve the two equations. So the first one, we solve for if we are looking for the positive value. So what kind of x I can plug in here to get a positive value, positive 7, which equates, oh, my battery is low, which is surprising. 30%, that's okay. So we have 2x equals 4 and x equals 2. And I always recommend everyone to use indexes. So the first point on our number line is a 2. And let me draw that right away. So here's my number line. It goes from infinity to minus infinity with a 0 in the middle. And here we have a number 2. Let's solve, I'll use a different color. So let me use a pink. Now I'm looking for the side where we have an absolute bracket, so which means that we can look for the negative number. So again, I will throw the number 3 to the other side, which is minus 10, and now divide by 2, which is minus 5. So this is my second point on the number axis, which is right here, a minus 5. I'll show you the second version of drawing the number line, is that you can draw the point here. So you can have an empty point right here. And now our interval that we're interested in, let me just increase my width, is in fact in the middle. So it's right here. This is our interval that solves our inequality, and we can prove it. Now, when we're uncertain, always try to test. So let's test out the theory if I take out a minus 3. So let's take out a minus 3 and let's plug in into our inequality right here. So we're asking the question. So let's try. And I'm going to try in green. So we have 2 times minus 3 plus 3, and I'll put it 7. Okay, so let's check if this is satisfied. We have a minus 6, we have a plus 3. This is the same thing as well, minus 3. And an absolute value changes the value to a positive 3. The absolute bracket kind of disappears. And we see that, in fact, this is correct. In other words, this number satisfies, is correct. And I guarantee you, if you would try this number, this number, this number, this number, all the way up to, and not including 5, so the closest you can get is 4.999 periodic. You can never reach number 5. Also with number 2, you can never reach number 2. The closest you can get is number 9999 periodic. All right. Since I promised 3, let's do a very quick one. So a number 3, let's say that we have the absolute value of 3x. Let's go with a minus. Let's go with a minus. We didn't have a minus x. Minus x plus 1, and let's throw it in a number 2. And in fact, let me throw in right here a plus 4. What happens? What happens? We just simplify. Again, you want to get a nice clean inequality. So the first one is, hey, I see that number 4, and I put equals, pardon me. Let's go with just larger than. Let's go with larger than 7. Don't like how thin my pen is. So first of all, I'm going to throw this to the other side because I don't need it. So it simplifies to a 2. And now I chose a very thick pen, but I think I'll just stick to it. And 7 plus 4, you're just treating it as if there's an equals. Also, this 2, we're going to throw on to the other side. So this is multiplication. This will be division. So our new, or let's say simplified inequality is minus 3x plus 1 is larger than 5.5, but I'm going to use fractions, so 11 over 2. And now we have to solve for the two equations. So right now we're going to the positive side, so minus 3x. We're looking for x's such that this is positive 11 halves. Yeah, so we're looking for x. The simplest way is, hey, I'm going to throw my 1 to the other side. Now I'll do this relatively fast. I mean, this is primary school almost, like working with fractions, or like middle school. So minus, it gives 9 over 2, and I again divide by 3. So my first x is minus 9 over 6. If you don't understand, just try it out yourself. I'm going to simplify. So it's 3 over 2. So my first point is 3 over 2. The second point we have to solve. So 3x plus 1 equals negative 11 over 2. I'm going to throw this guy to the other side, which now becomes, where's my green? My green is right here. Right now it becomes minus 13, so it grows by 1. And my x2 is minus 13 over 6, which cannot be further simplified. So this is our first point, and this is our second point. Apologies there. And when you draw the number line, you can find the solution.